Here's a solution to number 17. You've got a 150 Newton bird feeder supported by cables as shown. First of all, drawing the forces on it. The two tensions in this case are not going to be identical because they're acting at different angles. And just to avoid it, I didn't draw the tension up here. Instead, I drew the force of gravity down here. What do we know has to be true about all of these? They must add up to zero because we must be equilibrium. Yes, I could draw the tension over down here as being 150 newtons like I drew down here. But in this case, just for clarity, I'm going to take it out. You'll see why in a second. We know that some of these have to add up to zero. How do we solve it? Well, adding vectors, we're going to break these into their components. And just real quick on this one, opposite triangles, this will be 30 degrees down here. This will be 60 degrees over here. And we can use our equations, sine and cosine, to find these two sides. In this case, the opposite side is going to be T2 times the sine of 30, the adjacent side times cosine of 30. Likewise, on this, they have to be equal as well. We know that these two horizontal components must be equal to each other. I know they don't look that way in this diagram, my fault. But those are the only two horizontal components. They must be equal and opposite so that they add up to zero. And then finally, what do we know has to be true about these two vertical pieces? These two vertical pieces must add up to the 150 Newton weight, which is acting downward, so that the sum of the vertical forces add up to zero. So we can write two equations. First one, the sum of these two vertical pieces must equal that 150 newtons that we have, the weight down here. That takes care of the vertical portion. And then horizontally, the two horizontal components must be equal to each other. So T1 cosine of 60 must equal T2 cosine of 30. At this point, it's just algebra. We've done all the physics, now it's just math. You can plug in the actual sine and cosine values, if you like, as decimals, and do some substitution. And if you do that, or if you use the simultaneous equation solver on your calculator, you'll discover your two answers are that T1's about 130 newtons to 3 sig figs, and T2 is 75 newtons. In fact, exactly 75 newtons. I hope that helps.